Good morning, children. Welcome to the online webinar classes conducted by Tsrs&Jc. This is Maths to be Coordinate Geometry, Circles, Class 14. Dear children, before starting today's class, let us recapitulate the concepts that we have studied in our previous class. Dear children, in our previous class, we have discussed the number of the common tangents for the given circles depending upon their relative position. For example, if C1, C2 is greater than R1 plus R2, then the circles x is equal to 0 and x dash is equal to 0 are apart from each other. They do not have any point in common. In that case, there exist four common tangents for the circles x is equal to 0 and x dash is equal to 0. In the four tangents, two tangents are direct common tangents and two tangents are transverse common tangents. These four common tangents are the common tangents depending upon the relative position of the given circles x is equal to 0 and x dash is equal to 0. We have discussed the definitions of internal center of similitude and external center of similitude. What is internal center of similitude? The point of intersection of transverse common tangents is internal center of similitude. And the point of intersection of direct common tangents, if exists, is called external center of similitude. We have also discussed the procedure to find those points. Internal center of similitude, P divides the line joining C1, C2 in the ratio of radii of the circle, that is R1 is to R2 internally. Therefore, P is equal to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Here m is to n is equal to R1 is to R2. And x1, y1 is equal to center of the first circle minus g1, comma minus f1. And x2, comma y2 is equal to minus g2, comma minus f2, the center of the second circle. Similarly, we can find out the external center of similitude Q by using negative sign in the ratio formula. That is mx2 minus nx1 by m minus n, comma my2 minus ny1 by m minus n, where m is to n is equal to r1 is to r2, and x1 y1 is equal to center of the first circle minus g1 comma minus f1, and x2 comma y2 is equal to center of the second circle minus g2 comma minus f2. Dear children, let us take today's content. We shall discuss problems and solutions on relative positions of the circles. We shall also discuss the problems on the concepts, the combined equation of the pair of tangents drawn from an external point Px1, y1 to the circle x is equal to 0 is x into x1 is equal to x1 square. Let us also do some problems on finding the equations of direct common tangents and discuss the procedure of finding the transverse common tangents. Let us take the problem number 1, children. Show that the circles x square plus y square minus 6x minus 2y plus 1 equal to 0, x square plus y square plus 2x minus 8y plus 13 equal to 0 touch each other. And find the point of contact and the equation of the common tangent at their point of contact. Dear children, let us write the given circles. X is equal to first circle and x dash is equal to second circle. And let C1 and C2 be the centers of the circles x is equal to 0 and x dash is equal to 0. That means C1 is the center of the first circle and C2 is the center of the second circle. Similarly, R1 is the radius of the first circle and R2 is the radius of the second circle. Then C1 equal to minus G1 comma minus F1. That is from first circle 3 comma 1, and C2 is equal to minus G2 comma minus F2. That is from second circle minus 1 comma 4. And R1 is equal to root of G1 square plus F1 square minus C1. Substituting the values, minus 3 square plus minus 1 whole square minus 1 whole to the power of 1 by 2 is as equal as under root of 9 plus 1 minus 1, which is equal to root 9, 3. As it is difficult for me to take the root symbol in this PowerPoint presentation, I have taken the power 1 by 2 children. The power 1 by 2 are the root means one and the same. Similarly, R2 is equal to, these values are from the second circle. G2 square plus F2 square minus C2 whole to the power of 1 by 2 is as same as under root of G2 square plus F2 square minus C2. So simplification gives us R2 is equal to 2. Now, C1, C2, the distance between the centers is under root of x2 minus x1 whole square plus y2 minus y1 whole square. Substituting the respective values, 3 comma 1 as x1 y1 and minus 1 comma 4 as x2 y2, we get C1 C2 is equal to under root 25, which is equal to 5. Now, R1 plus R2 is equal to 3 plus 2, which is 5. So we observe C1 C2 is equal to R1 plus R2. Then what will be the given two circles, children? They touch each other externally, and the point of contact is internal. Observe the figure, children. How are the two circles touching? They are touching each other externally, but the point of contact is internal, that is on the line segment C1 C2. And P divides the line joining C1 C2 in the ratio of R1 and R2. Since the circles touch each other externally, the point of contact is internal. Let P be the point of contact of the given circle H is equal to 0 and H dash is equal to 0. Then P divides C1 C2 in the ratio of radii of circles. Therefore, P is equal to R1 into minus G2 plus R2 into minus G1 divided by R1 plus R2, comma R1 into minus G2 plus R2 into minus G1 divided by R1 plus R2. Then P is equal to 3 into minus 1 plus 2 into 3 by 3 plus 2, comma 3 into 4 plus 2 into 1 by 3 plus 2, from which P is equal to 3 by 5, comma 14 by 5. Now we have to find out the equation of the common tangent, that is tangent for x is equal to 0 and x dash is equal to 0. At the point of contact, P 3 by 5, comma 14 by 5 for the circle x is equal to 0. What is the formula to find out the tangent, children? X1 equal to 0. Here, we have taken x is equal to 0, but we can also take x dash is equal to 0, children. It is one and the same because it is a common tangent. So you can take any of the circles. Now we have what is x? X is equal to x square plus y square minus 6x minus 2y plus 1 equal to 0. So s1 will be xx1 plus yy1 minus 3 times x plus x1 minus y times, minus 1 times y plus y1 plus 1. Now we'll find x1 xp, children. So x, what is x1? 3 by 5. Plus y, what is y1? 14 by 5. Minus 3 times x plus 3 by 5 minus y plus 14 by 5 plus 1. On simplification, we will get x1 as 4x minus 3y plus x equal to 0, which is the common tangent FP. Now let us discuss an important statement, children. Let P be an external point for the circle x is equal to 0. Then there exist two tangents from P to x equal to 0. Let PA and PB are the tangents drawn from P to x is equal to 0. Then the combined equation of PA and PB can be found by using the formula x1 square is equal to x into x11. The statement is as follows. The combined equation of the pair of tangents drawn from an external point Px1, y1 to the circle s is equal to 0 is x1 square is equal to x into x11. I request the children to work on the proof of this theorem. Let us solve a problem related to the concept we discussed. Now, we shall find the equation of the tangents from 10, 4 to the circles x square plus y square equal to 25. First, let us write the given point, children. P10, 4. Let us take this as x1, y1. And the circle x is equal to x square plus y square equal to 25. The combined equation of the pair of tangents drawn from an external point Px1, y1 to the circle s is equal to 0 is s1 square is equal to s into s11. What is x1 for the given circle, children? X1 plus y1 minus 25. I forgot to write minus 25, children, here. Now it will be x1 plus y1 minus 25. So x1 plus y1 minus 25 whole square. X1 square. So let us take whole square. So x1 plus y1 minus 25 whole square is equal to x square. We have s, which is x square plus y square minus 25 is equal to x1 square plus y1 square minus 25 is x11. Now x1 plus y1 minus 25 at P10, 4. Therefore, in place of x1 we will write 10 and in place of y1 let us write 4. On simplification of above equation, we get the equation 9x square plus 80xy minus 75 square plus 500x minus 200y plus 2900 as the equation of the tangents drawn from 10, 4 to the circle x square plus y square equal to 25. That means it's a combined equation of the tangents drawn from P to the circle x is equal to 0. Using which formula, children? x1 square is equal to x into x11. Now assignment. Find the pair of tangents drawn from 0, 0 to the circle x square plus y square plus 10x plus 10y plus 40 is equal to 0. Dear children, we shall solve the problem. Find the equation of the circle which touches the circle x square plus y square minus 2x minus 4y minus 20 externally at 5, 5 with radius 5. Dear children, we have a circle and a point. Let us write that given circle S is equal to x square plus y square minus 2x minus 4y minus 20 and the point P 5, 5 is equal to x1, y1. Center of the given circle C1 is equal to 1, 2 and radius of the given circle under root of d square plus f square minus t is minus 1 whole square plus minus 2 whole square minus of minus 20 whole to the power of 1 by 2, which is root 25 is equal to 5. And let C2 is h, k. Let C2 h, k be the center of the required circle. And radius of the required circle is R2. And R2 value is equal to 5 given. We need to find the equation of the circle with radius 5. That means Required circle radius is 5. Look at the diagram, children. The first circle is the given circle. This is given circle with center 1, 2 and radius 5. And let the second circle is the required circle. The radius is 5 and this circle is touching the first circle at point P5, 5. We don't know the center of the circle. We only know the radius. If we know the center of this circle, we can find the equation of the circle. Since we don't know the center of the second circle, let H, K be the center of the second circle. Now our aim is to find the center. If you observe the figure, children, P is dividing C1, C2 in the ratio of R1 is to R2. In the ratio of R1 and R2. But here R1 and R2 are same. That is, C1P is equal to PC2. So, we observe that P is the midpoint of the line segment C1, C2. Can we write the midpoint formula, children? Yes, x1 plus x2 by 2, comma y1 plus y2 by 2. So, P5, 5 is equal to 1 plus h by 2, comma 2 plus k by 2, from which h, k is equal to 9, 8. That is center of the second circle. So, we know the center and radius. Therefore, equation of the circle is x minus h whole square plus y minus k whole square is equal to r square, which will be x minus 9 whole square plus y minus 8 whole square is equal to 5 square. On expansion, this gives x square plus y square minus 18x minus 16y plus 81 plus 64 minus 25 equal to 0, which implies x square plus y square minus 18x minus 16y plus 120 equal to 0. Now, let us discuss the method of finding the direct common tangents of the circle. X square plus y square plus 22x minus 4y minus 100 equal to 0 and x square plus y square minus 22x plus 4y plus 100 equal to 0. Dear children, let us denote the first circle with S and the second circle with S dash. Let C1, C2 be the centers and R1, R2 be the radii of the given circle. Then C1 equal to minus 11, 2 and C2 is equal to 11, minus 2. R1 is equal to root of 11 square plus minus 2 whole square minus of minus 100, which will be root 225, which is equal to 15. Here, instead of root, I have taken power 1 by 2, children. Similarly, R2, radius from the second circle, it is root of g square, 11 square, plus f square, 2 square, minus c, minus 100. Children, in the second circle, it is g is minus 11. By mistake, I have taken 11. But when we square, again it will be plus 11 whole square. It doesn't matter, but we should write the correct value as minus 11 whole square, children. Now, R2 is equal to under root of 25, which is 5. So, we got C1, C2, R1 and R2. Let us find external center of similitude Q. Dear children, in the previous slide, we observed R1 is not equal to R2. When R1 is not equal to R2, Q exists. When R1 is equal to R2, then the direct common tangents does not intersect. Here R1 is equal to 15 and R2 is equal to 5. Therefore, R1 is not equal to R2. So, I choose a method in which external center of similitude Q is equal to R1 into minus G2 minus of R2 into minus G1 by R1 minus R2, comma R1 into minus F2 minus R2 into F1 by R1 minus R2. Here Q is equal to 15 into 11 minus 5 into minus 11 by 15 minus 5, comma 15 into minus 2 minus 5 into 2 divided by 15 minus 5. From which q is equal to 22 comma minus 4. Now, our direct common tangents pass through q. Then, equation of any line passing through q and with slope m is y minus y1 is equal to m into x minus x1. Point slope form of a straight line children. Here x1, y1 is q 22 comma minus 4. On substituting, y plus 4 is equal to m into x minus 22. Now our aim is to find the value of m. As this line 1 is a tangent for both x is equal to 0 and x dash is equal to 0. Let us take this is the tangent to the x dash is equal to 0. Then radius of this circle is equal to perpendicular distance of the line 1 from the center of the second circle. So what is the formula, children? Radius we got already, R2 is equal to 5, and perpendicular distance from the center of the second circle to the line. M into 11 plus minus 1 times minus 2 plus brackets minus 22m minus 4 divided by under root of 1 plus m square. Squaring on both sides. 25 times 1 plus m square is equal to, on simplification, on right hand side, it is minus 11m minus 2 whole square. On right hand side, taking minus common won't affect the equation because it is squared. It comes as 25 times 1 plus m square is equal to 11m plus 2 whole square. On expansion and simplification, we get 96m square plus 44m minus 21 equal to 0, which is a second degree equation in m. So, factorizing this equation for m, we get 96m square plus 72m minus 28m minus 21 equal to 0. That can be written as 4m plus 3 into 24m minus 7 equal to 0, from which m equal to minus 3 by 4 and m equal to 7 by 24. So corresponding to m equal to minus 3 by 4, we will get one tangent. We will get one common tangent. And m is equal to 7 by 24 gives another common tangent. So let us take the cases. Case 1, if m is equal to minus 3 by 4, what will be the equation, children? Y plus 4 is equal to m into x minus 22 is the equation 1. In that, we will substitute m equal to minus 3 by 4 and simplifying, we will get 3x plus 4y minus 50 equal to 0 as the one of the equation of direct common tangent. And for m is equal to 7 by 24, our equation will be y plus 4 is equal to 7 by 24 times x minus 22. On simplifying which, we get 7x minus 24y minus 250 equal to 0. Therefore, 3x plus 4y minus 50 equal to 0 and 7x minus 24y minus 250 equal to 0 are the required equations of the direct common tangent for the given circle x is equal to 0 and x dash equal to 0. Dear children, I have explained that the procedure that so far we have discussed works when R1 is not equal to R2. Only in the case the two direct common tangents intersect, then Q exists. Then we are finding the equation of a line through Q. But there is also a case when the given circles are with the same radii. Then what happens if R1 equal to R2? As the direct common tangents won't intersect. Look at the diagram, children. The two direct common tangents are not intersecting in this case. Therefore, external center of similitude does not exist. Then we use the following method to find out the direct common tangents. Let y is equal to mx plus c be the direct common tangent equation. And let us take the given circle x is equal to 0 and x dash is equal to 0. We have to find out the centers of the two circles C1, C2 and radii of two circles R1, R2. We observe that R1 is equal to R2 implies the line segment C1, C2 is parallel to direct common tangents. Isn't it, children? From the diagram, are you observing? Yes. Therefore, the slope of direct common tangents M is equal to slope of the curve C1, C2. Dear children, you know C1 and C2 from the given circles. So, can we find the slope of C1, C2? Yes. Using the formula y2 minus y1 by x2 minus x1, from which we will get the slope of the direct common tangents M. Therefore, in the equation y is equal to mx plus c, you have got the value of m. Now, we shall find the value of c, for which we use the condition r equal to d. If this y is equal to mx plus c is a tangent for the given circle, then it must satisfy the condition r equal to d. So let y equal to mx plus c be the required equation of the direct common tangent. Since this line is a tangent to x is equal to 0, of course for x dash is equal to 0 also, we have r1 is equal to d. We can also use r2 equal to d, children. Here R1 is the radius of the circle x is equal to 0, and d is the perpendicular distance from the center of the circle to the line. So R1 is equal to d is the value of c in y equal to m plus c. Substituting these values of m and c, we get y equal to mx plus c as the equation of the transverse common tangent. Hence, the equations are obtained. Method of finding the equation of transverse common tangent. Dear children, if you observe the two circles in the diagram, the transverse common tangent is intersecting at a point P. So, the transverse common tangents are the tangents passing through P. Let C1 and C2 and R1 and R2 be the centers and radii of the given circles respectively. Then we have to find out the internal center of the liquid P. Let L is equal to 0 be the line passing through P with slope M. Now to find the slope, then we have a slope and a point. L is equal to y minus y1 is equal to m into x minus x1. Substituting P here, we will be remaining to find the value of m. If this line L is equal to 0 is the equation of the tangent to any of the circles x is equal to 0 or x dash is equal to 0, then what is the condition for a line to be the tangent for the given circle, children? You can either take first circle or second circle. Then the condition is r equal to d. If you take the first circle, it is r1 equal to d. This condition gives us the value of m. Substituting this m value in the equation 1, as we have done in the direct common tangents, we get two equations if two m values exist. Those are nothing but the equations of the transverse common tangent. Dear children, today's assignment is complete the exercise 1E, bit 2 and bit 3. With this, we have finished the exercise 1E of the chapter circle. Thank you, children. Have a great day.